Enterprise architectures face a persistent bottleneck, reconciling massive concurrent billing streams from disparate upstream systems into a single compliant financial ledger. Millions of fragmented billing events, from subscriptions, one-off purchases, and usage metrics, collide simultaneously. Without a structured containment system, this influx threatens to compromise the integrity of the subledger. This diagram maps the solution. Convergent invoicing sits at this intersection, capturing external billing, CRM, SD, and CC data. Notice the invoicing in FICA block. Instead of a single monolithic write, it orchestrates creation through a strict multi-step execution sequence. To transform these temporary data triggers into locked FICA documents, SAP relies on a precise 7-step pipeline. Understanding this exact sequence is mandatory for solution architects. It is the only way to safely inject custom business logic without breaking subledger integrity. Mastering this pipeline allows an architect to deploy convergent invoicing as a highly configurable engine for financial orchestration. The sequence initiates with Step 1, data selection. The system does not wait for manual inputs. It constantly scans for pending actions. The gatekeeper for this process is the DFKKINV_TRIG table. When a billing document is generated, it creates a temporary entry here called an invoicing order. Looking at this workflow, invoicing orders flow directly into the selection process to identify which billing documents require processing. The report reads the trigger table specifications, filtering for appropriate source documents and checking them against master data. This involves checking the main selection indicator. During mass processing, a contract account only qualifies for invoicing if at least one of its pending source documents carries this specific flag. Once these triggers are validated, the raw source documents are pulled from their holding state and pushed forward. This strict trigger-based selection isolates the pipeline from upstream delays. Only fully validated billing documents ever attempt to enter the subledger. Step 2 is the creation of invoicing units. The selected orders must now be bundled. By default, the system groups all billable items that share the exact same contract account, business partner, and currency into a single unit. This flowchart illustrates how architects override that default. The invoicing process branches through a grouping variant to control the creation of the invoicing unit. In this customizing view, variant 002 forces the system to split a customer's invoice based on the S part field, which represents the business division. You could also split based on company codes or contract references. The rule governing this step is absolute. One completed invoicing unit will always equal exactly one final invoicing document. With the units defined, the pipeline advances to Step 3, processing of billing documents. The bundled data is finally digested. The system physically links the individual billing document items to the header of the newly created invoicing document. Simultaneously, it performs the internal derivations required for the eventual posting into contract accounts receivable and payable. If you are running invoicing in dialog using expert mode, this is the exact moment an architect can manually intervene via a dialog box to alter the unit assignments. Ultimately, grouping variants act as the strict physical boundary logic, determining whether a customer receives one consolidated bill or several highly targeted ones. Step 4 activates additional functions. Here, standard data processing stops and dynamic business logic is injected into the flow. You can assign standard functions like generating dunning proposals, calculating late charges, or applying account-level discounts. Consider a complex edge case: digital payment cards. Prepaid scenarios demand instant payment clearing at the exact moment of invoicing, meaning the invoice and the payment must be processed together. By activating the specific invoicing function pcard_payment, the pipeline intercepts and processes the credit card data simultaneously with the invoice creation. This function calculates the authorization data from the external system and prepares a separate secondary posting document strictly for the card settlement. This forces the pipeline to generate document type 0PCP for the credit card payment alongside the standard 0INV revenue document. These functions are assigned at the invoicing process configuration level, ensuring they are entirely modular and event-driven. Invoicing functions allow solution architects to embed complex financial operations directly into the processing pipeline, avoiding the need for heavy ABAP customization. Step 5 tackles account maintenance. Before any new financials are committed, the system must reconcile historical data. Account maintenance is the automated clearing between the newly drafted posting documents and any existing open items on the contract account. This configuration screen displays clearing control, which provides the strict rule set for how these open items are grouped, sorted, and applied using specific characteristic values. Take a baseline example. The system detects an existing $20 credit from a budget billing request. It prepares to offset that credit against a new $30 invoice debit. The pipeline automatically clears the historical credit against the new charge, leaving only a newly calculated $10 open balance for the customer. Architects can heavily restrict this step. For instance, using Posting Area 2630, you can configure your system to permit the clearing of cash security deposits only during a final billing process. Integrated account maintenance ensures that the final generated invoice always reflects the true, real-time net financial reality of the customer. Step 6 is the update phase. Up until this precise millisecond, everything has been a simulation. Now, the transaction is finalized. The newly created invoicing documents and FICA posting documents are permanently written to the financial ledger database. Next comes the critical cleanup phase. The system actively deletes the original DFKK-INV_TRIG invoicing orders to guarantee they cannot be double processed. Finally, Step 7, print preparation. The pipeline decouples the financial database write from the physical print job to maximize system performance. The system generates a correspondence container for downstream invoice printing and an extraction order to update the business warehouse, successfully concluding the pipeline. From the initial trigger detection to the final generation of the correspondence container, this sequence represents a complete financial lifecycle. The true power of convergent invoicing is that this exact pipeline operates on millions of records concurrently, entirely in the background. Returning to our architectural map, we see the results. By decoupling billing generation from financial posting, SAP allows businesses to handle massive transactional volume without bottlenecking the general ledger. Extensibility is built directly into the flow, primarily through grouping variants in Step 2 and invoicing functions in Step 4. Manipulating these specific configuration nodes allows the system to adapt to almost any modern billing scenario, from telecommunications to digital streaming services. Mastering this execution pipeline provides the technical foundation required to design and scale complex convergent invoicing landscapes.